Okay, so here is just some little helpful tidbits on numbers 3 and 4, which means I hope after doing these two, you'll be able to do number 7. Okay, so here we go. You're giving this function, and you're asked to find the value, the local approximation of f of 1.3. Now, if you have to, pause this. I mean, I cut and pasted the question out, but hopefully you know where the question's coming from. All right, so I'm going to use a linear approximation at x equal to 1. Now, for starters, don't forget what we talked about in class. F of x is equal to f prime of whatever that number is, a, times x minus a plus f of a. Okay, and don't be scared. F prime, remember, is dy dx at x equal to whatever a is. Okay, a in our case is basically what is given to us. And I think it says x equals 1, right? That's where this guy came from. And of course, f of a would be f of 1. So I'm hoping all that tends to make sense. Notice that I'm trying to do my approximation within the interval they give me. So that's a check. All right, so that's good. Okay, now it does mention it's concaved up. So immediately it's an underestimate. Okay, and the reason being is because remember, if it's concaved up, whether it's decreasing or increasing, your tangent lines, those linear approximation lines, will be under the curve. So it would have to be an underestimate. So for starters, you can cross out those overestimate ones. That's not going to happen. Okay, so here we go. Let's find our values. F of x is equal to f prime. Now remember, you're going to have to figure out what f prime is at the point that gave me 1, -2. So 1 goes in for x. I think where people were messing this one up is you forgot the square first. So remember, square the -2, you get 4. And then, of course, you have 1/2 minus 1/4 of a positive 4, which gives you a -1/2 for your dy dx. So this guy's a -1/2. X minus a plus f of a. Now remember, f of 1 is the y value, which is -2. Okay, and again, I think that's also messing some people up. Not you all, though, of course. So here we go. We have 1/2 x minus 1 minus 2. Now, we have to figure out what f of 1.3 is. So we're going to take 1.3 and plug it in and do a little shimmy, shimmy, work. Okay, that's nothing but a heartbeat. 1.3 minus 1 minus 2, 1/2, 0.3 minus 2. And then, by the way, this guy right here ends up being was that 0.15? Oh, I'm sorry. This is -1/2. I left a negative that. My bad. So it's a -0.15 minus 2, which is -2.15. So it has to be that value. Okay. All right. I know I did that kind of fast, a little bit all over the place, but hey, you're pretty smart. So if you have any questions, give me a holla. Now let's look at number 4. Okay. Number 4 was asking about the limit as x goes to infinity of f of x over g of x. All right, so for starters, we know f of x was, of course, 2x plus 3 e to the -5x over g of x. All right, now it says find the limit as x goes to infinity. Well, if I put infinity in, this guy's going to infinity, but this guy's going to 0, okay? We already were told that g of x, the limit of that one, is going to infinity. So you end up getting infinity over infinity, which means you can do L'Hopital. And remember, that's the whole point of this lesson, was being able to do L'Hopital. Remember, this is it, indeterminate form. So what that means is take a derivative of the numerator, which is 2. Now, the derivative of this piece here, 3e to the -5x. Remember, the derivative of e to the u is e to the u times the derivative of u. And that's why this whole thing becomes a -15 e to the -5x. I think that's the trickiest part. They already told me what g prime is. I don't even have to calculate that. They gave it to me, which was very nice of them. Okay, here we go. Send x to infinity. Well, that piece is going to 0, like we said. 1 over x is going to 0. 5 over x is going to 0, but now we have 4 times cosine of 0, which, oh, by the way, is 4. So you end up with 2 over 4, which is 1/2, and that was one of your answers. Okay, so I am really, really hopeful that this made some bit of sense. And like I said, number 7, I think, is just like number 4, so I bet you could probably do number 7. All right, give me a holler if you still have questions. Goodbye.